All right. So first, I am Shannon Hogue. I am somebody who helps developers find the right monitoring tools to be able to grow with some velocity, do it sustainably, and hopefully have a little bit of fun at work, right? That's me, right? Today, I want you to walk away with some confidence that if you move towards serverless, which a lot of people are, that you can monitor. There is a way to see what's going on in your application. It's that easy, okay? So I'll talk a little bit first about why I'm in monitoring. I'll tell a story, and it looks like all the TED Talk people do that, so I'm gonna try it out. So I started writing software, I'm dating myself, back in 1997, okay? I came right out of high school, and I thought I was the master of the universe. I did. I thought I was the smartest person in the room, right? Came from the Midwest, got invited to live in Silicon Valley. I had it going on, right? And I had a decent career for about 10 years, and then something happened. It was that moment for me, right? That moment that I realized that I didn't know anything, right? It took me 10 years. I'm a little slow. Okay. So I worked for a company. The CTO, my boss, was Al Alcorn. Does anyone know him? Invented Pong? No? Anyone play Pong? Jesus, I'm old. Oh, good, thank God. Al Alcorn is a brilliant mechanical engineer, and they built this amazing software, but they needed a little bit of help, okay? The VP of engineering, I don't know if anyone's heard this story, but he built everything in Perl. Anyone know Perl? Anyone hate Perl? Yeah, me too, okay? It was impossible to find developers, obviously, right? And it didn't scale so well. Now this was like, 10 years ago at least. And they used the public version of MySQL and dumped terabytes of bits in the database and had 8-hour outages. And we're like, whoa, why is this happening? We have this great architecture. So they hired me, master of the universe, right? So I thought it was like a slam dunk. It was. I'll bring in a Java architect, bring in the latest technology. I bought $1 million in Blade servers, $1 million. Anyone do that? Oh God, I'm the worst. So I bought, and we saved it, right? We took the bits out of the database, we bought Oracle, we went all the way. 8-hour outages, they were gone. We were the best, right? But the old VP wasn't so happy. So he talked to the CEO, who didn't like me very much because I apparently have an attitude, I don't know. Well, at least then I did, because master of the universe. And he brought in a few experts. And the experts decided that they wanted to hear why Java and all this money spent was better, right? So they put us head to head with the old VP. Not a joke. Like, by the way, if any company does this to you, run. It's really a bad thing, okay? I know we like confrontation here in Israel, but this is a bad one. So we get in the room, and I thought it was a slam dunk, right? The outages were gone. We were flying, taking in terabytes of data, doing all our processing. Woohoo, we had reports in real time instead of weeks later. Okay, so it's good stuff. Great. And then Al, he goes, okay, that's cool, but how do I know that's true? I was like, what do you mean? We don't have outages. He's like, yeah, where's the data? And I went, oh no. We didn't have any monitoring, none. And he reminded me, you have to make data-driven decisions, right? And at that point, I became obsessed with monitoring. Obsessed, right? Because I had to. He made me look like an idiot, right? No longer master of the universe. My cape was gone. I couldn't function. I knew everybody in Silicon Valley must know how stupid I am, right? So this was my aha moment. This is why I work to help developers innovate, okay? So, why should you spend time with me? Well, the Al Alcorn story was cool, so I'm hoping that works for some of you. First, you want to know what serverless is. I'll do my best. Second, you want to know what distributed tracing is. Cool. And for those of you who know, please don't embarrass me. And third, you're dying to know the surprise ingredient to those two having the perfect marriage. Okay? Good. Anyone want to leave? All right, we're doing good. What is serverless? This is the one slide that I'm actually going to have you read or read myself because they have much better words than I do. See point number 3, okay? Serverless computing is a cloud computing execution model in which the cloud provider acts as the server, dynamically managing an allocation of machine resources. Pricing is based on the actual amount of resources consumed by an application. Thank you, Wikipedia. Very good. On martinfowler.com, there's a great article about serverless. I hope all of you go read it. His colleague says serverless architectures are application designs that incorporate third-party backend as a service services and or that include customer code, run and manage, God, I'm running out of breath trying to read all this. Run and manage ephemeral containers on a functions as a service platform, okay? Yours truly just says, yep, serverless is amazing, right? But today, one of my colleagues, a very, very brilliant colleague, one of my favorites, told me that serverless, it's a community. I thought that was interesting. He's like, yeah, because when I code with serverless, I'm working with so many third parties. It's like, I never know who's going to join the party, right? Anyone have that in serverless? No? Yeah? Okay, good. It's a good start. Thank you, Martin Fowler. Why do we care? Why do we care? Well, it looks to me like the top growing cloud services year over year has been serverless. It overtook container as a service. We've had a lot of conversation with people that just skipped containers altogether, okay? It's important, and whether you like it or not, serverless is coming. Who's who in the zoo? Lambda's in the house. Nice. We got Google Cloud Functions, IBM, Oracle, and Microsoft. And what we are seeing is that Amazon's in the lead, but Microsoft has some love in the enterprise space, I'm not gonna lie, sorry, bud. And then we see Google Cloud Functions. But today I'm gonna focus on Amazon because, you know, they're in the room. I stole a couple of slides. This is my first. This is from a talk from the PM of serverless from about a year ago. We all know the journey. Who's from the monolithic age? Me, that's me. Who moved to Ruby on Rails to the service-oriented architecture age? No? God, thank God, Rails was terrible. Sorry, Rails people. And then we started getting really smart about debugging, right? We started thinking about breaking things into pieces so that it was easier to find root cause, right? Easier to manage for everyone but DevOps, but we'll talk about that, right? And I didn't steal his next slide, but it's the most important one. All of these three things have one thing in common, at least. One very scary thing. Anyone want to guess? No? Servers, right? I'm an old programmer. I did Windows development. When I had to start building web apps, I was like, oh God, someone's gonna break in. I don't know what I'm doing. I gotta hire someone quick, right? It wasn't fun. And it got to the point for me where I was doing more configuration management than actually coding. Who likes that? That's boring. It's boring. Well, for me. And I'm terrible at it, so I'm going to say it's boring. Because remember, master of the universe. So, what's the answer? For me, anyway. Woohoo! Serverless. Serverless. Not having a server is just one of the many benefits. Right? And the last speaker hit on a few of these, right? It's pay per use. In Amazon's case, per 100 milliseconds of compute. That's pretty cool. Pretty cool. You don't have EC2 sitting around wasting all your money. This is nice. It's auto-scaling. All of the providers that I put up there, they know what they're doing when it comes to auto-scaling, certainly better than I do. Right? And it increases developer velocity because you are finally coding. How many people in here are developers? Ooh, DevOps, Ops, IT, network? Yeah, network guys hate us. Yeah, come on. I was listening to a talk earlier and they were talking about finding packets. I was like, oh God, no way, never. I'm terrible, not smart enough. So what does that mean? With those three things, all of a sudden you can iterate faster and faster and faster. And if you think that your competitors aren't doing that, you're wrong, okay? People are using serverless to build software faster, all right? And people are saving 50 to 80% on their infrastructure, but you know, I don't know how many business people are in here. It's compelling, mostly for my C-levels. So what's the catch? Sounds like the promised land, the perfect answer to all your problems, right? Just like microservices, Ruby on Rails, Amazon, right? Promised land. right? Well, that's the problem. Anyone see this slide before? Good. Yeah, you've been to some serverless stuff. Okay, I don't want questions from you. Yeah, Jan Kui, he's awesome. He's also an AWS Lambda hero. All right. And this, guys, is the real representation of a monolithic application gone to serverless. How many are scared now? When I saw this, I got scared. I was like, ooh, how am I going to manage that? Right? It's scary. It's scary. When I think about traditional monitoring, when I think about monitoring for me growing up in my career as Master of the Universe, I worked at New Relic. Full disclosure, I loved it. I'll always be a Relic. I thought about servers. I thought about my application server. I thought about monitoring, lines of code. It's great, right? Doesn't quite work here, okay? Like my buddy said, it's a community. This is a community. As we get smaller and smaller pieces and we only want to pay for that 100 milliseconds, we're not going to rebuild cryptography, an authentication engine. We're not going to rebuild any of that, right? We're going to stick to our core competencies, which is good. We all have those developers that are better than everyone. But we're also going to have to focus on third-party services. We have to use them, right? So we're no longer now talking about a single function. We're talking about an ecosystem. So in walks distributed tracing. Everybody in here knows what a trace is. I'm not going to lecture you. Majority of people probably figured out that distributed tracing is basically a way to profile monitor applications, watching a workflow, a transaction from end to end. You remember that big old picture? Imagine that somebody logs in and maybe 3 or 4 of those nodes are circled. That's it, right? So distributed tracing is a great way to get visibility into largely distributed asynchronous applications. Does anyone think that's not true? Perfect. I love you all. I can go. Like I did my job. Okay. I'm going to do the why do we care because I think there's some brilliant people that work in the industry. And I basically want to copy off their papers. So Brandon from Lightstep. I don't know if you guys, anyone know Lightstep? Okay, we're going to talk about them in a little bit, actually. They have great history. So Brandon from Lightstep, basically, distributed tracing, it's table stakes, right? My favorite, Remshi. Distributed tracing will become a default. And our friend George Lawson talks about why. Better for optimization, root cause analysis. There's going to be a lot of splah in the room. This is not a perfectly accurate representation of the history. This is me trying to make it fast and move on because you could take a long time on how distributed came to be, but how we came to be, or at least I came to be here, started 2007, 2008 at Google with Dapper, the first distributed tracing system that I heard about. Eventually, the work that was done there has transformed into open tracing. It's a CNCF standard, and also the base of a lot of technologies out there today. It's great, no question. And from there, a lot of companies have come, whether they're built on top of open tracing or not, but they understood that distributed tracing is a great way to get visibility into your architectures, right? Know what's going on. Herd those cats, developers that you got, right? So, who are the cat herders? Lightstep, we talked about Lightstep. Lightstep is founded by one of the gentlemen who helped write the paper for open tracing. Okay? They are a white glove service monitoring company. They're going to come in with some brilliant engineers, ones I've worked with, by the way, and they're going to ask you what's important to you, right? And then they're going to show you how to add tracing, and then they're going to set up this amazing dashboard, and they're going to set up monitoring for you. It's a good company. Zipkin, Jaeger, these are open source tools, tool sets, visualizations built on top of open tracing. Datadog, who knows Datadog? Yeah, it's a cool shirt. Datadog also has some open tracing implementations adding to the efficacy of their APM product. And then there's us. Okay? We have our own bespoke distributed tracing technology. So This is the full disclosure part. I did not ask you to come in here for a 30-minute infomercial on why you should buy our product, okay? But it is my job to tell you why we have the philosophy that you have to marry distributed tracing with serverless and add a little secret sauce to make it effective, okay? So there's a lot of other philosophies out there, bunch of people focusing on the function itself. We just take it a different direction. So in order to understand why we took it a different direction, understand the secret sauce, let's talk about what it takes to implement. It's cool. You add code before and after your calls. You add code at the end of your microservice. And unfortunately, it's a little high maintenance and high potential for errors, right? Let me ask you this. You got a bunch of microservices. It's the middle of the night. You're fixing a bug, or you're trying to finish a feature. It's due the next day. What is the first thing that drops off a cliff? Tests, right? Tests. You know what the second thing is? That's what happens. We hear time and time again that people can't trust that every single one of their Lambdas or their microservices actually has implemented tracing. They get lost because in some enterprises in particular, it's hard to keep track of all the services and functions and microservices, right? And with functions, this is an even bigger problem. You got thousands and thousands of functions. How are you going to track whether or not they added the tracing? And if they didn't, how do you know if these are unused or if they're part of a purchase? How do you manage that? So, again, serverless applications are very distributed. They have thousands of functions. So if they got to add all that code, what happened to that third benefit? The developer velocity, right? Make sure I'm not keeping you too long. It's gone. And then add the other challenges of serverless applications, out-of-memory conditions, timeouts, the dreaded cold start, concurrency limits, retries. How many people even knew there were retries? We have a lot of conversations with people who don't. Yeah, it costs you money. Yeah. I'm not telling you it doesn't work, but this is where I get to our philosophy, okay? Don't worry, let's automate. For my operations guys, my IT guys, it saved at least my butt 1,000 times when you guys automate what I do, right? Automation can keep up with the velocity, okay? So you don't lose the problem. So our philosophy at our company is that you should automate tracing, that you include a library, and all the tracing is done automatically. And we do, right? Low footprint, you don't have to add any code, install our library, include it, add it to your serverless framework, and you see this. True end-to-end, right? What else do you see there? Third parties, right? There's a whole lot of people that are focusing on the insides of your AWS Lambda account. X-ray, right? It's not going to tell you about those third parties that could be causing you problems. And we learned that the hard way. Okay? Quick overview of monitoring. Track system health, check. Troubleshoot and fix, check. Optimize performance and cost. We all understand that these, good reason to monitor. We also understand that in Lambda, time is money. So, we have distributed tracing. It's automatic, right? Now we need to figure out where we spend the most time and optimize. So I'm going to show you a few examples of where we failed, okay? Everyone likes a failure story. So we eat our own dog food at our company, and we use serverless and AWS, okay? And, we were scanning CloudWatch logs and, running every 5 minutes, saving it to RDS. Well, guess what? And a new Lambda. We did it the serverless way, by the way, AWS, right? We had a new Lambda spawn for every customer's function, async. It seems right? It's easy. I don't have to read Hebrew to know what that text says. Can you all see it? No? Yeah. We thought we were doing things right. We didn't have any errors. All we had were a bunch of retries. Retries, remember? They're expensive, And then that could have happened. But we saw where the bottlenecks were. We saw the cost, and we remediated. So what happened? Why did our function that cost us pennies on the dollar end up costing us potentially $12,000? Well, CloudWatch got highly throttled, right? You can only make 5 requests at a time. So what happened? We had 5,000 concurrent Lambdas trying to hit CloudWatch. So 5 of them got in, and the rest, they're waiting, trying again, waiting, trying again. Bam, $12,000, right? If you're not scared, you should be scared. This happens all the time. Let's give you another example. Not necessarily a failure, but talking about bottlenecks, and I'm going to try and go super fast. I got about 3 or 4 minutes. 2 minutes, perfect. All right. This is a transaction that happens often for us, often for our customers, right? This is distributed tracing. As you can see, this is an actual visual from our software, okay? Request comes in the API gateway, triggers the Lambda, bam, everything's okay. Then authentication happens on this transaction, 702 milliseconds. The entire transaction only took a second. So 70% of the time you're paying for is that third-party API. I'm sorry, Auth0. Is there anyone from Auth0 here? Yeah, okay, good. Why is that important? Well, it may have been an anomaly. It may only happen once. Or it could be a trend. So you can't just get transaction information individually. You can't just look at the functions and try and go through 70 logs and figure out that it was Auth0. You need to take a look at your entire system holistically, and you need to get aggregate data of performance over time. Okay, as you can see, if I just looked at the Lambda there in the middle, I may not know which business transactions were affected. Right? There may be different code paths for the different requests. I don't know. Now with 15-minute limits, it's going to get worse. Thanks, AWS. Okay, so business flows are important. Aggregated data is important. Visibility is important. And the secret sauce is automation, right? Okay. One last slide, just so you understand kind of the benefits of having that aggregated data. Code optimization. This is a table. Tells you for an entire transaction, aggregated information, invocation count, and so on. You can look at this, and in the New Relic way, you can look at your top 5 slowest running transactions and decide to go make some optimizations. Okay, look, the biggest thing, takeaways. You guys all know what serverless is now, I hope? Yeah, okay. Distributed tracing? And the secret sauce? Yeah, okay, good. Whew. Just send a little love today, okay? Please don't forget the perfect marriage. Do not focus only on your functions. You will lose track, I promise you, okay? All right. Yay, how'd I do? 2 minutes. Yay, I made it. Thanks, you guys.